Well, hello there. We're going to be talking about momentum in collisions today. Today we're going to learn about identifying the different types of collisions, how momentum will be conserved, and calculate the initial and final momentums. Here again is our equations. Okay, types of collisions. The first type of collision is an elastic collision. An elastic collision is like when a tennis ball hits the ground or anything hard hits the ground, they bounce, right? They bounce off each other. In inelastic collision, the best example of an inelastic collision would be like when a bug hits a windshield. They stick together. So inelastic collisions are when things stick together. Elastic collisions is when they bounce off of each other. All right, conservation of momentum. And the main thing we have to realize is that the momentum before is going to equal the momentum after. So before the collision, a 10 kilogram ball rolling 3 meters per second hits a 2 kilogram ball rolling 5 meters per second. Well, the momentum before must equal that which is after. What that tells us then is afterwards we have a 10 kilogram ball rolling at 1 meter per second and the 2 kilogram ball is rolling at 15 meters per second. Well, let's see how this turns out to be before we had 40 kilogram meters per second and after we had a total of 40 kilogram meters per second. To start off with, we had this 10 kilogram ball going 3 meters per second. And that gives us 30 kilogram meters per second. We had this 2 kilogram ball going 5 meters per second. And that gives us 10 kilogram meters per second. Well, what is 30 kilogram meters per second plus 10 kilogram meters per second? It gives us the 40, a total of 40. Well, after the collision, we have a 10 kilogram ball. Still, the masses didn't change, but its velocity has changed. It's changed from 3 to 1. So it now has a momentum of 10 kilogram meters per second because 10 times 1 gives us 10. And now we still have a 2 kilogram ball, but it's now rolling at 15 meters per second. So 2 times 15 gives us 30 kilogram meters per second. So afterwards, we still have 40 kilogram meters per second when you add up the 10 and the 30. The momentums of the balls changed, but the total momentum stayed the same. Well, how do we set up a before and after table? Up here at the top, all right, up here at the top, I've given you the basic example of how you start off. And what we said originally was that the first ball had 30, the small ball had a momentum of 10. That gave us a total of 40 kilogram meters per second. Afterwards, we said that the large ball, its momentum had gone down to 10, the small one had gone up to 30, and it still gave us a total of 40 kilogram meters per second. Now, I've typed an example down here for you to look at, so you can go back and look at the examples. But I had a car, 1,000 kilograms, 15 meters per second. It had 15,000 kilogram meters per second momentum. There was a truck, 3 times as large, going only 3 meters per second. It had 9,000 kilogram meters per second. If you add those, you get a total of 24,000 kilogram meters per second. After the collision, this car hit the truck. It was going faster than the truck. It runs into the rear end of it. All right, the car now has a speed of 10 meters per second. The speed changed from 15 to 10, so the momentum went from 15,000 to 10,000. All right, that 10,000 is what's important. The truck had a mass of 3,000 kilogram meters per second, and its velocity has changed. But we know that it has to have 14,000 kilogram meters per second. Well, how do we know that? Because we start off with 24,000. We know that the car has 10,000. So if you subtract those two, it tells you that there's 14,000 kilogram meters per second left. They're missing. So who's got to have it? The truck's got to have it. And so we put that in for momentum. We put the mass in for its mass of 3,000. We solve for velocity. Well, the velocity of the new velocity of the truck has to be 4.7 meters per second. Otherwise, momentum's not going to be conserved. All right, so let's do a little before and after here in this case. I'm going to pause this and give you a chance, and then when you pull it back up, I'll have a lot of it filled in. All right, as you can see here, I've already found the momentum of the truck, 2,000 times 4, the momentum of the car, 1,000 times 2, for a total momentum of 10,000 kilogram meters per second. Then from there, afterwards, the truck had slowed down to 3 meters per second. 2,000 times 3 is 6,000. We had a total of 10,000, so I took the 10,000 minus the 6,000 that the truck has, and that tells me that the momentum of the car is equal to 4,000 kilogram meters per second. So I put the 4,000 in for momentum, the 1,000 kilograms is the mass of the car, solve for the velocity is 4 meters per second. Hopefully that was a little simpler than you thought it was going to be. Hey, I want you to give this a crack here. We've changed this up here a little bit. I'm going to pause it here in a second, give you a chance, and when you pull it back up, I'll have most of it done for you. Okay, before the collision, the truck had a momentum of 8,000 kilograms. The car had 2,000 kilogram meters per second again, for a total of 10,000 kilogram meters per second. The truck afterwards, well, that's what we're going to find out. All right. The car had 10,000 kilogram meters per second. If we subtract that from the original, right, if we take how much momentum the car has from the total originally before that collision, that tells us that there's 0 left for the truck to have. So I can put 0 in for the momentum of the truck, and as you start to find out very quickly, the velocity of the truck is 0 meters per second. It has stopped. It's not moving at all. Well, hey, hopefully this has been informative for you. If you have any questions, we'll discuss that tomorrow. I'll see you on the flip side.